Assalamualaikum and good afternoon. My name is MOHD KHAIRUN NIZAM bin Muhammad Arifuddin. I would like to give special thanks to my supervisor Encik Muhammad Kamal bin Arifin for giving me opportunity to present my PSM1 proposal. My PSM proposal 1 uh, is to study of cooling load using cooling load temperature difference CLTD method in gas turbine area gas district cooling PUTRAJAYA plant 2. The presentation outline is number 1 is to introduce introduction, number 2 why cooling load calculation, number 3 problem statement, number 4 objective, number 5 research scope, number 6 literature review, number 7 methodology, number 8 expected result, and last number 9 Gantt chart. For the introduction, thermal and atmospheric condition is an enclosed space are usually controlled in order to ensure the health and comfort of the occupants or the proper function of sensitive electronic equipment, such as machines that have a limited range of temperature and humidity tolerance. Therefore, heating, ventilation, and air conditioning HVAC play an important role in ensuring the temperature in an enclosed space is at ambient temperature. When an heating, ventilation, air conditioning system is operating, the rate at which it removes heat from a space is the instantaneous heat extraction rate for that space. The concept of a design cooling load derives from the need to determine an HVAC system size that under extreme condition will provide some specified condition within a space. The space served by an HVAC system commonly is referred to as a thermal zone or just a zone. Usually, the indoor boundary condition associated with a cooling load calculation is a constant interior dry bulb temperature, but it could be a more complex function such as thermal comfort condition. What constitutes extreme condition can be interpreted in many ways. Generally, for an office, it would be assumed to be a clear sunlit day with high outdoor wet bulb and dry bulb temperatures, high office occupancy, and correspondingly high use of equipment and lights. Design conditions assumed for a cooling load determination are subjective. However, after the design conditions are agreed upon, the design cooling load represents the maximum or peak heat extraction rate under those conditions. Why cooling load calculation? The cooling load calculation is the first step, the interactive HVAC design procedure. Number 2, right sizing the HVAC system, selecting HVAC equipment and designing the air distribution system. At the point number 3, the cooling load calculation result will have a direct impact on first construction costs along with the operating energy efficiency, occupant comfort, indoor air quality, and building durability. Why I select gas turbine area? Gas turbine area in gas district cooling PUTRAJAYA plant 2 is enclosed space and too hot. For this system and the turbine area, fire alarm system was installed in this room, and this alarm may be activated automatically from smoke detectors and heat detectors. Since all the equipment in this room is running 24 hours and produce heat, it might activate the fire alarm system if the room temperature is too high. Currently, a few fans were installed to exhaust the heat from the space and to maintain this area temperature at ambient temperature, but the area is still hot. Hence, heating, ventilation, and air conditioner HVAC play an important role in ensuring the temperature in enclosed space is at ambient temperature, and cooling load calculation by CLTD, cooling load temperature difference method, will be carried out. For the objective, The objective of the study is towards cooling load estimation for gas turbine area in gas district cooling Putrajaya Plant 2. The data from the research may use to provide information on equipment selection, system sizing, and system design. The research scopes for this study is to collect data in the gas turbine area in gas district cooling Putrajaya Plant 2. Cooling load calculation method are based using ASHRAE Handbook 1977 Fundamental. Cooling load calculation by cooling load temperature difference method will be carried out. For the literature review, I have conducted 5 literature survey for my study. For literature survey number 1, the title is Cooling Load Estimation for Library, was conducted by Anurag Kumar Singh. The objective for calculation of thermal load of room is done for the selection of right size of air conditioner in order to achieve optimized energy at required temperature, humidity, and proper distribution of air. The conclusion through the calculation is to obtain the total heat gain in the library and give the suggestion for the size of air conditioning system. For the survey literature number 2, title cooling load estimation of a room was done by Deepak and friends. This paper gives the result of cooling load evaluate in different climate conditions by using CLTD method. The calculated result will compare with standard data given by ASHRAE and Carrier Fundamental Handbooks, and the results are satisfactory. For the literature survey number 3, the title is Analysis of Heat Gain in Computer Laboratory and Excellence Center by using CLTD, CLF, SCL method, was done by MD Suziana and friends. The purpose of this calculation is to identify component of heat gain in order to conduct energy efficient study of the whole building. And the conclusion is the assessment of cooling capacity produced by air conditioning system show that the air conditioning produces overcooling for 23.7 and 25.8% for computer laboratory and excellence center rooms. Management should reduce the cooling capacity produced by the air conditioning in order to reduce energy consumption. For the literature survey number 4, the title is Heat Gain Study of a Residential Building in Hot Dry Climate Zone on basis of 3 cooling load methods, was done by Antima Sharma and Namarata Singha. The aim of the paper is to study the heat gains and also to compare the 3 different methods. In order to reduce the heat gain and cooling load, major attention must be paid on roof and wall heat gain along with the other factors. Suitable passive measures can be identified on the basis of the heat gain study. And for the final literature survey, the title is Cooling Load Estimation using CLTD CLF method for educational building of Institute of Engineering and Technology, Devi Ahilya Vishwavidyalaya Indoor, was done by Mukesh Vaskel and Sharat Chaudhary. The paper is to aim calculated the manual cooling load estimated for summer season, applied the method to the indoor. These methods are very widely used by air conditioning engineers as they yield reasonable accurate result, and estimates can be carried out manually in a relatively short time. That method accounts for the combined effect of inside and outside temperature difference, daily temperature range, solar radiation, and storage in the construction building mass. And the conclusion is the load calculation is done for the 2-story education building. Through the calculation, it is obtained. The total heat gain in the ground floor is about 72,483 watt, approximately 20.71 ton refrigerant, and first floor is about 145,360 watt, approximately 41.53 ton per refrigerant. The maximum heat gain from the roof about 24.44% of the total heat. Principle of cooling load. The cooling load is the amount of heat energy that will need to be removed from a space to maintain the temperature in acceptable range. Components of cooling load. The total building cooling load consists of heat transferred through the building envelope, such as wall, roof, floors, windows, doors, and etc. And heat generated by equipment, and lights. The load due to heat transfer through the envelope is called as external load, while all other loads are called as internal load. As you can see, the figure is an example of cooling load component. The load due to heat transfer through the envelope is called as external load. The total building cooling load consists of heat transfer through the building envelope, such as walls, roof, floors, windows, doors, and etc. While all other loads are called as internal load, such as heat generated by equipment, and lights. Methods for calculating the cooling load. Number 1. Transfer function method TFM. This is the most complex of the method proposed by ASHRAE and requires the use of a computer program or advanced spreadsheet. Methods number 2. Cooling load temperature differential, cooling load factors, CLTD, CLF. These methods derive from the TFM method and use tabulated data to simplify the calculation process. The method can be fairly easily transferred into simple spreadsheet programs but has some limitations due to use of tabulated data. Method number 3, total equivalent temperature differential time averaging, TETD and TA. This was the preferred method for hand or simple spreadsheet calculation before the introduction of the CLTD/CLF method. Cooling load methodology. Design cooling load takes into account all the loads experienced by a building under a specific set of assumed conditions. Weather conditions are selected from a long-term statistical database. The condition will not necessarily represent any actual year, but are representative of the location of the building. ASHRAE has tabulated such data. The solar loads on the building are assumed to be those that will occur on a clear day in the month chosen for the calculation. The building occupancy is assumed to be at full design capacity. The ventilation rates are either assumed on air changes or based on maximum occupancy expected. All building equipment and appliances are considered to be operating at a reasonably representative capacity. Lights and appliances are assumed to be operating as expected for a typical day of design occupancy. Latent as well as sensible loads are considered. Heat flow is analyzed assuming dynamic conditions, which means that heat storage in building envelope and interior material is considered. The latent heat gain is assumed to become cooling load externally, whereas the sensible heat gain is partial delayed depending on the characteristics of the conditioned space. According to ASHRAE regulations, the sensible heat gain from people is assumed 30% convection, instant cooling load, and 70% reactive delayed portion. Peak load calculation evaluate the maximum load to size and select the refrigeration equipment. The energy analysis program compares the total energy used in a certain period which varies various alternatives in order to determine the optimum one. Space zone cooling load is used to calculate the supply volume flow rate and to determine the size of the air system, ducts, terminals, and diffusers. The coil load is used to determine the size of the cooling coil and the refrigeration system. Space cooling load is a component of the cooling coil load. The heat transfer due to ventilation is not load on the building but a load on the system. Method of solution. CLTD, CSL, CLF. The total cooling load is divided into external load, internal cooling load, and loads due to infiltration and ventilation. The external load consists of heat transfer by conduction through the building walls, roof, floor, door, etc. Heat transfer by radiation through fenestration such as windows and skylight. All these are sensible heat transfers. The various internal load consists of sensible and latent heat transfer due to occupants, product, process, appliances, and lighting. The lighting load is only sensible. The conversion of sensible heat gain from lighting, people, appliances, etc. to space cooling load is affected by the subject to appropriate cooling load factor (CLF) to account for the time lag of the cooling load caused by the building mass. The weighting factor equation determines the CLF factors. CLF equals to Q cooling load divided by Q internal gains. Note that the latent heat gains are considered instantaneous. For the light, the primary source of the heat from lighting comes from the light emitting elements. Calculation of this load component is not straightforward. The rate of heat gain at any given moment can be quite different from the heat equivalent of power supply instantaneously to those lights. Only part of the energy from light is in the form of convective heat, which is picked up instantaneously by the air conditioning apparatus. The remaining portion is in the form of radiation, which affects the conditioned space only after having been absorbed and released by walls, floor, furniture, and etc. This absorbed energy contributes to space cooling load only after time lag, with some part of such energy still present and radiating after the lights have been switched off. For the power loads, the industrial and commercial appliances use various equipment such as fans, pump, machine tools, elevators, escalators, and other machinery which add significantly to the heat gain. There are 5 equations in use for different scenarios. For the appliances, in a cooling load estimate, heat gain from all appliances, electrical, gas, or steam should be taken into account. Because of all the variety of appliances, applications, schedules, use, and installation, estimates can be very subjective. Often the only information available about heat gain from equipment is that on its nameplate. Inflation air. Inflation air, where the airflow rate is calculated, including the sensible and latent heat. For supply fan heat load, supply and or return fans that circulate or supply air to the space and heat to the space or system depending on the location relative to the conditioned space. The heat added may take one or all of the following forms. Instantaneous temperature rise in the air stream due to fan drive inefficiency. Temperature rise in the air stream when the air is brought to static equilibrium and the static and kinetic energy is transformed into heat energy. The location of the fan and motor relative to the cooling coil and space being conditioned determines how the heat is added to the system. If the fan is downstream of the cooling coil draw through, then the fan heat load is added to the space cooling load. If the fan is upstream of the cooling coil, Then the fan heat load is added to the system cooling coil load. Ventilation air. Ventilation air is the amount of outdoor air required to make up for air leaving the space due to equipment exhaust, exfiltration, and or as required to maintain indoor air quality for the occupants. The heat is usually added to the air stream before the cooling coil has no direct impact on the space condition. Duct heat gain. The return ductwork system is extensive and insulated or pass over a non-conditioned space. Only the heat gain by the duct supply system is significant. The heat gain is normally estimated as the percentage of space-sensible cooling load, usually 1% to 5%, and applied to the temperature of the air leaving the cooling coil in the form of temperature increase. Duct leakage. Air leakage out of or into ductwork can have much greater impact than a duct heat gain or loss. Outward leakage from the supply duct is direct loss of cooling and or dehumidifying capacity and must be offset by increased airflow or reduced supply air temperature. Leakage into a return duct system causes additional cooling coil capacity, but it does not directly affect the space condition. Commercial type or existing older system can have leakage from 10% to 20% of the total system airflow. Per energy conservation guideline, in a new installation, the duct system should not leak more than 1% to 3% of total system airflow. The engineer or designer is cautioned to make sure that the proper allowance for leakage is included in the calculation in order to ensure that the equipment selected is properly sized. For the diversity factors is defined as the ratio of the sum of the maximum demands of the various parts of the system to the coincide maximum demands of the whole system. Maximum demands of the individual consumers of a group do not occur simultaneously. Thus, there is a diversity in the occurrence of the load. For my for my uh, study, I will use industrial diversity application. The factor lights is 0.0 to 0.90 and for the people is 0.85 to 0.95. Methodology. As you can see from the slide is my flow of study. First, I will get information of the gas turbine area, such as orientation of the building, building location, climate condition, building specification, and others data. Data we collected based on ASHRI 1997 Fundamental Handbook, September to October 2020. The general step-by-step procedure for calculation based on ASHRI 1997 Fundamental Handbook. Calculation will be done using equation mentioned in Chapter 2, CLTD method we carry out. The calculation of the cooling load of will be presented on a worksheet. And finally, the data collection and analysis. As you can see, this is the example of the worksheet. All of my data will be tabulated and calculated using this worksheet. The expecting result. The load estimation of the gas turbine area can be done and calculated as below. Load through glass, load through ceiling, load through floor, velocity of infiltration, room sensible heat gain, room latent heat, room total heat, outside air sensible heat gain, outside air latent heat gain, outside air total heat, grand total heat gain, and tons of refrigeration. This is a Gantt chart for my studies. That's all for my presentation, and thank you.